Today we are going to start the very first chapter of ncert grade in chemistry, that is chemical reactions and chemical equation. We can classify or divide this chapter into 5 topics: introduction to chemical reaction, writing the chemical equation, balancing the chemical equation, types of chemical reaction, and effects of oxidation and reduction in everyday life. Let's get started. Introduction to chemical reaction. Before moving to the idea of chemical reaction, let me recall the concept of changes. There are two types of changes: physical changes and chemical changes. The changes in which physical properties are changed are known as physical changes. The changes in which chemical properties are changed are known as chemical changes. In physical changes, it is reversible in nature and there is no new products are obtained. But in the case of chemical changes, it is irreversible in nature, same time new products are obtained. That is the exact point. New products are obtained. The process in which new products are obtained and they are irreversible in nature are known as chemical changes or chemical reaction. That means chemical reaction and chemical changes both are same. So we can define the chemical reaction as the process in which one or more substances, or we can call it as a reactant, they combine together or they react together to form one or more other or new substances, which is known as product. Many people, they think that chemical reactions happens inside the chemistry lab only. No, it's a wrong concept. We can find out millions and billions of chemical reaction around us. For example, burning firewood, or conversion of milk into curd, or resting of iron. There are millions or billions of chemical reaction around us. Even there is millions of chemical reactions happening inside our body. For example, digestion of food, respiration, or preparation of hormone. These kind of chemical reaction happen in our body. If there is any chemical reaction happening, imagine, let it be burning of wood, conversion of milk into curd. If there is any chemical reaction is happening, and how we get to know that that chemical reaction happened or taken place? In order to identify that, we will consider certain observation such as changing state, changing temperature, changing color, evolution of gas, and formation of precipitate. Out of these 5 observations, if any observation is present, we can say that a chemical reaction has taken place. Move to the second topic, that is writing chemical equation. What is writing? What do you mean by writing chemical equation? What is chemical equation? Before moving to that topic, we will consider one experiment. Here we have a magnesium ribbon and we are burning this magnesium ribbon in the presence of air, and we are getting a white colored magnesium oxide. During this process, we can observe a dazzling flame on the magnesium ribbon, and in the end, we are getting a white colored magnesium oxide. If I want to write this experiment in a paper, how I can write this experiment in a paper? We have 3 methods for writing one experiment in a paper. They are, we can write an experiment in the form of sentence or sentence form, or in the form of word equation, or in the form of symbol equation. These are the 3 methods which we can adopt for representing one experiment in a paper. First, we will consider sentence form. How to write magnesium burning experiment in sentence form? We can write in this way. When magnesium ribbon is burned in the presence of air, we got white colored magnesium oxide. Don't you feel it is little bit lengthy? How we can reduce the length and make it simple? We know that we are adopting writing this equation in word equation form. Okay, so how to write in word equation form? We know that here magnesium is there, burning means reacting with oxygen, and we are getting magnesium oxide. So we are writing the same experiment in the form of word equation. It can be written like this: magnesium plus oxygen. Why we are taking oxygen? Because burning is happening. Magnesium plus oxygen, and we are getting and we are getting yielding, it is represented by an arrow, and we are writing magnesium oxide because that is the product. And for representing reactants we use words, and for showing the reaction we have used a plus sign. Here it seems little bit lengthy, right? So we can try how we can write the same reaction in the form of symbol equation. Okay, we know that magnesium, what is the symbol of magnesium? That is Mg. And what is the symbol of oxygen? O2, because oxygen is diatomic in nature, so we can use O2 as the symbol of oxygen. And what is the symbol of magnesium oxide? That is MgO. That is already discussed in 9th standard, right? So instead of the words that we have already used in word equation, we will rewrite the words by using symbols. So the simple equation will be Mg plus O2 gives, by using an arrow, and MgO. So don't you feel it is the simplest way to represent an equation? So far we were explaining how to represent a chemical reaction in 3 ways, which are the sentence form, word equation, and symbol equation. To make the symbol equation more informative, we can use some more symbols such as S for solid, for showing that reactant or product formed is a solid. If it is a solid, we can use S, or L for liquid, G for gas, or instead of G we can use upward arrow also for representing the reactant or gas. Reactant or product is a gas. Aqueous, AQ for representing aqueous, and downwarded arrow for representing precipitation. If a precipitate is formed during a reaction, we can use a downwarded arrow, and we can put a triangle for representing burning. So these are the some more add-ons for making the symbol equation more informative. So let's try, or let's see how we can use these symbols in a word equation. If we are using these symbols in our word equation, burning of magnesium ribbon, the equation will be like this: Mgs, because magnesium is solid in nature, plus O2. O2 is a gas, so G for gas, and we are burning, right? So in under the arrow we will put that triangle for representing burning, and we are getting MgO, magnesium oxide, which is solid in nature again, so we will put S over there. So this is the way we can make this equation more informative.